good. It's gonna happen. It's gonna happen however it happens. It'll be fine.
Don't worry about it. We will just.
But I will have to go home. I will have to go home though and grab my card. So we can probably do
Yeah, wait until they start doing the presentations.
yeah, shoot a presentation to you.
Yeah,
Okay.
totally. All right.
Okay.
There we go. So first thing I've learned is we're coffee deficient. So we'll get you some coffee to get started here. I'm Michael Helser. I'm the Assistant Director of the Milgard Center for Business Analytics. And of course, this is the MSBA Applied Project Showcase, my favorite event of this program. And I hope it is for you. I see a lot of nervous faces and all of that, but this is an exciting day for you to share the hard work and the collaboration with your community partners. I can't wait to see it. It's going to be just terrific. And we have a lot of folks here that I'm really happy to see. First of all, we have our 2022 MSBA students. Raise your hand. All right. Good to have you here. We also are fortunate to have some of our applied project community partners, and I know Jason is here. Anybody else here from our community working with our students? Terrific. Thank you, Jason, for coming from Sound Credit Union, a great partner of ours. I also invited alumni who have done this in the past. Do we have any alumni? Oh, you got Michael. We have Michael. We just can't quit you, Michael. And then I invited our incoming MSBA students, and I've seen some already. Will you raise your hands so you can all know who each other are? Terrific. You know, it's such a good idea for you to come here and have a chance to see what's next for you a year from now when we celebrate yours. And so please bump into any of the students that are currently presenting. The poster session is also a really good time to get to know. They have a lot of tips and tricks after a full year of this program, so take advantage of that. She is not here. I wish she was. Anne-Marie. I want to give a big thanks to Anne-Marie Martin. She is my colleague and partner in all of this, and she's my Dutch colleague, and she always complains. There she is. Woo! That's the boss. She's always telling me that Americans say thank you too much. I'm American, and I'm going to say thank you anyway, Anne-Marie. Just this one time. So we're going to have an opening here that will be some words from Professor Haluk Demirkan, our Chief Innovation Officer of the Milgard School of Business, founder of the CBA program and the MSBA program, a mentor and a friend, and a terrific professor. So we're really excited to have you. I'll have you come up in just a moment. The order of events today will be some opening remarks. Then at 9:15, we're going to get into the good stuff, all the presentations. So we'll go through presentations 1 through 8, followed by our AI Club presentation as our 9th presentation. With regard to technology, we have an HDMI plug-in here, so if you're running your demo, you can do that. Work amongst your teams to find what adapters you might need. We also have all your presentations preloaded onto here, so if you haven't made any changes since you submitted those, they're ready to go for you too. Let's see, at 11:30, sorry, at 11 we'll do a short intro session. I'm going to do a call for applied project proposals, a little bit about the CBA and MSBA program. Lunch is arriving at 11:30. Of course, all the students, and if you've registered and you're not, we'll have a lot of lunches. Enjoy a lunch. We've got a lot of options coming at 11:30 for networking. And then 12:30 to 1:30, we'll have the tables moved around. We'll have the poster session. We'll do another call out for the campus to bring more people in, hopefully to see your great work, and then you're done. And then I'm going to host a little get-together at Seven Seas Brewery, and that'll be from 1:30 to 3, and I really hope you can join us there. Exciting day, welcome, enjoy it, and I can't wait to see the presentations. I'm going to hand it over to Luke.
Thank you. All right. So, do I need to play with the slides, or?
You can do whatever you like.
I wasn't sure. Anyway, good morning, everybody. I guess welcome back. I remember all of you from last summer. I don't know if you remember last summer, I said, time will go by very fast, which it did, right? I mean, 12 months of marathon, because, and probably Michael, now on, we should start taking a picture first day and last day of the program, and then we can see a lot of energetic, full of energy, and very athletic-looking people, and then towards the end, everybody's a little tired, more gray hairs, no hairs, a little bit gaining weight, because of the whole 12 months of marathon. So I guess congratulations to all of you, because I think I mentioned many times, you really should feel really good about this, because when I did master's degree, it was a 2 years program. I mean, it literally took me 2 years. Most master's degrees are actually 2 years. And now maybe few master's degrees are maybe 16 or 18 months, but there are really very few 12 months. So when you really think about it, you literally did 2 years worth of work in 1 year, right? And your brain is probably hurting with a lot of information right now, a lot of stuff. Most of you probably like, oh my God, I got so much in my brain. What am I gonna do, or what am I gonna start doing? So it is a great feeling, basically. You should feel that way. You should be really proud of yourself and your families, your partners, your kids, because when you do these 1 year master's degrees, actually everybody at home does that master's degree, in my opinion, right? Because when you study, somebody else takes extra work. So from that, you should really feel well about this. Okay, if I can, I'm not much a technology guy. Oops. All right, I can just do it here. This is always safer. So I remember, I'm sure most of you have remembered this slide from last summer. So with this MSBA program, we are really trying to do something very different. And as you noticed, this is extremely multidisciplinary. Each of you have a very different background and coming from different disciplines, different education and work experience. So we really wanted to do this multidisciplinary program. And I know this also creates a lot of challenges, right, which happens. It's part of the learning. So, I mean, I wanted to just few things about these questions. So what do you think? Machines seem to be getting smarter fast. Agree or disagree? Agree, yeah. Machines are getting smarter than us, most of us. How about people? Are we getting wiser? Compared to speed of technology change? Probably not, right? But it is really interestingly, even machines are getting better. We are not getting wiser. I have a very basically instant experience I had last night. Yesterday, we bought a new laptop for my wife, and then we took it home. I was like, okay, today's century, it shouldn't take more than 15 minutes to set up this laptop. Oh my God, it still took 3 hours to set it up. Brand new laptop, out of box. So why do you think so? Any ideas? Because of complexity, right? When we have so much stuff going on in the laptop, there are also lots of complexities behind the scene. And for example, I wanted to install a virus check software to her laptop. It requested about 15 times user ID and password to set up a virus check software. So the complexity is also getting bigger than used to be, right? So I have a couple other. So it's becoming easier to analyze data. Still yes or no, right? It is really still yes or no. Because we have lots of hidden patterns are growing in data, right? And then innovation needs to happen rapidly. Yes or no, kind of, right? And then adaptability. So I really wanted to bring this up. So my suggestion is, when you finish this degree, you have more than enough data, technology, information systems, all those knowledge, okay? My biggest suggestion to you to start to become more adaptable. How easily you can change. It is not easy. It's not easy how we work or how we do things. But I personally think this is becoming the biggest key today to be successful, especially in the professional work environment. Being adaptable, being able to change fast, very quick, because of things are moving so fast. That's why I wanted to, because adaptability of everything, right? And so that's the one thing I wanted to mention. And then I have actually this slide from a few years back. It is amazingly how slow academic or education progress compared to technology change today. So this is another thing I wanted to basically mention, because education usually behind the technological change, always, right? So what it means is when you graduate, it's not going to end today. Your education is not going to end today. You will have to learn almost something new every day. I'll be honest with you. If you stop learning, you're going to be obsolete. There's no question, especially in today's world. So what I mean is basically, even after today, I strongly suggest you to think, okay, what am I going to learn next? It can be anything, right? But you have to figure it out to self-educate yourself. I mean, what people call it lifetime learners. I think this generation, all of us, are lifetime learning right now, right? So I will be honest with you. When I finished my undergrad degree many, many years ago, only thing I wanted to do was just have a degree when I did my undergrad many years ago. And I was like, okay, I want to finish my undergrad. That's it. I'm done with education. I'm done with schooling. And actually, after I finished my master's undergrad degree, I studied 9 more years, by the way. So my family was actually extremely surprised. They were not expecting me to do even have a master's degree. So what I mean is you need to figure it out how to get some additional education after finish the master's degree. So you all heard about this T-shape, pie-shape. Now things are changing. I know when I studied college degree, I was I-shaped. Then we were talking about T-shape. Now people are becoming more actually pie-shaped. So with the adaptability, so having more skill sets and knowledge. And then basically, basically, academic education, somehow we are behind how things are changing outside of the school. So with our Masters of Science Business Analytics program, with the CBA, with Applied Project, we really wanted to address that gap. We wanted to speed up as much as possible. That's why we really appreciate for your all hard work for these applied projects, because you have done a lot of work, a lot of free work actually, right? So that's the truth. But you should really feel good about it because you have accomplished a lot with these applied projects. And so this is just one of the last slides about so this is what we try to do. We hope we accomplish this learning curve with the MSBA program. And of course, we have lots of more work to do with the applied projects and curriculum with our programs. But again, every year, even with our MSBA program, our applied projects, we really want to improve it. So we would love to hear from you how we can take the MSBA program or applied projects to the next level. Because again, if we stop learning ourselves, or if we stop changing our programs, we will fall behind. So that's the thing I wanted to mention also. And then this is just a quick, spill about our MSBA program. We want to have more students, of course. So please let your friends, colleagues, if they have any interest to study, right? And then these are just the basic statistics Michael may also share this afternoon. So including you, we have been doing applied projects last 5 years. So far, we finished 65 projects, and with 42 organizations, over 250 students. So it means, including you, we have 251 alumni now. So, which is a good number, I think, in 5 years. And then, so this year, thank you to all. We have 9 projects, including the AI Club project, with 35 graduate students. And I guess this is my last slide, actually. Welcome to the Milgard School Showcase, I guess Applied Project Showcase. Thanks. All right, thanks, Michael. I don't want to take too much time.
Okay, we'll go ahead and start with Team 1. And what I'm going to do is, I'll have a timer going, and I'm going to just put 1 minute left, just so you can have that. Ideally, you won't see this, and you'll be done before there's 1 minute, so we have a chance for questions and answers. All right? And we have 1 microphone, so you'll just hand it to each other.
Awesome. Thanks. I think it's easier if I disconnect. It would be easier if I disconnect. Yeah, that sounds good. We're just going to set up for 1 moment, please. Just hold. Oh, we are on. Okay. Yep, right there. Hit it. Yeah, show me. MSBA team, yeah. You hit that right there. switch back to this guy. I've got to reload.
So we'll be able to hear everyone speaking into the mic.
Does this work?
It's connected to this guy, so you'll need to advance.
I'll just wait for the camera guy. Yeah, we're going to wait for him to start recording. Good morning, and thank you for joining us. My name is Abdullah. I am the project manager for Team 1, and this right here is Randall. He's also one of our engineers for Team 1, and our client is Virginia Mason Francescan Health. We're working with their mission control team on the ancillary service project now. Can you guys hear me? All right. Two things before we start the presentation. For those thinking, when did a hospital become a space program? It hasn't, not yet. But the idea of mission control is a command center over at the Virginia Mason Francescan Health's headquarters. And what this essentially, the objective is to funnel all the data from their hospitals, satellite offices, clinics, to visualize from one central location with the goal of driving insights from the data to figure out how to impact the triple bottom line positively, looking at the historical trends to see where the baseline is, but more importantly, where the future will take our client through this data. The second thing I want to provide context on is ancillary services. And for those who don't know, ancillary services is a department within all of our hospitals in the network. And the objective of this department is to take in services, execute, and provide results. Now, an example would be if medical personnel is serving on a patient care team, and the patient needs MRI. Sorry. Is that good? Better. All right. So if a patient needs an MRI, a CT, an echo, wound care, and so on, they would order such services, and the ancillary services would take in that order and execute and provide it. Now, in the perfect world, these orders would be returned in the fastest possible time, but because of the global pandemic and things like overpopulation and growth, it's taking much more longer than it should be. Next slide. Now, with today's agenda, I'll be introducing the team, the wonderful individuals who make up Team 1. We'll be going over our project. We'll be providing an overview of our end-to-end solution. We'll also discuss the accomplishments that we've made as a team in this year-long project. We'll discuss one of our solutions and the impacts, the important aspects of that solution. We'll touch base on our Power BI deliverable. We'll be doing a demo, and finally, we'll end up with our limitations, assumptions, concerns, and recommendation slides. Now, Team 1, these are the wonderful and very talented individuals I've had the pleasure of working with. From left to right, Randall, he's one of the team engineers. Vivek Mahal, she's one of our business and intelligence analysts. Viviana Ramirez is also another talented engineer. She's led our Power BI experience and experiments. I'm Abdullah. I led the team as the project manager. And lastly, Raul, who's been, I think, the instrumental part in our development throughout this year. Now, our project overview. Our problem within the ancillary services, it's simply because of a surge in patient volume, they cannot provide the adequate results in a timely manner. And with that, patient care is impacted negatively. And because of patient care being impacted negatively due to the extreme length of turnaround time, this results our client, Virginia Mason, to be liable for an increased length of stay. And what this essentially means is a patient has a recommended length of stay that is determined by healthcare regulators and the government and their insurance. And if a patient overstays that length of stay, the hospital is not liable for whatever cost occurs after that length of stay. Our goal through our prototype business analytical solution is to provide a solution that would, first of all, manage the surge in patient volume, but more importantly, provide patient treatment and care in a timely manner. And lastly, reducing the liable costs that are incurred from the patient length of stay.
Yeah, so what our team did was starting out the first quarter, we started the ETL process. So we were tasked with figuring out how to take our data in, and the current data was in a data lake that was unstructured JSON format, which is pretty dirty data. So we had to turn that into a tabular form, into a CSV for the whole entire year. The next step was we created visualizations, initial visualizations, using the data that we had cleaned. And then next, we had run statistical models using R programming language, and developed even more visualizations and deep learning with that. For the next step, we created Azure ML pipelines, which are pretty much just visualizations of machine learning algorithms. And finally, we uploaded all of our final forms of data this previous quarter into Python for machine learning algorithm testing as well, just to validate our machine learning algorithms.
Next, we're going to discuss what we as a team have done in this year-long project. So in phase one, it was more so getting understanding of who our client is, the industry they serve, and just analyzing their overall organization. And we did that by creating a project management plan. From there, we conducted our industry and market analysis, as well as our company analysis, like SWOT and the Porter 5 forces. Lastly, we conducted a scope management to prepare us for phase two. Now, in phase two, you've heard my partner Randy talk about how we did our SQL transformations and our Power BI visualizations. Now, before we were able to do such developments, we had to create a data management plan, which simply states how we're going to acquire the data, how we're going to manage it, and securely manage it, since it's hospital patient data. And from there, it's coming up with our descriptive and diagnostic analysis and preparing it to create our summary of findings and recommendations. Now, the important thing to note is in each phase after phase two, we have a series of summary of findings and recommendations, but they're tentative, meaning for every phase that we do development and research, those summary of findings and recommendations change to better cater our end goal, which is providing a solution to our client. In phase three, two more. In phase three, we've honed in on our Power BI visualizations, but we've started our Azure ML and our more of our R development. And from there, we moved on to phase four, which allowed us to finalize all of our developments while also creating a Power App solution and creating our transformation plan. And that plan laid out how we're going to transform all of our work and create two folders that are very crucial to this year-long project, which is tangible deliverables. A folder that has all of our developments, everything for our client to create on their side of things and roll it out to their organization. But the second one being project support. All the data they have to connect to, all the Excels, everything that's really required for the tangible deliverables folder to be successful. Next. Now, we're going to discuss one of our analytic solutions, and it's one of the many solutions that we've packaged into our tangible deliverables, and this is our StatCom app. And StatCom was used, we used Power BI to develop this prototype, and essentially what StatCom stands for is statistics command. Now, this statistic command would give our client everything that they need to know about ancillary services, and in a simple overview, it has a simplified UX and UI to ensure that anybody could use it. It only has two layouts, the landing page and whatnot, but we will discuss all that in the demo.
Yeah, so right here, this is the front page of our Power BI demo that we delivered to our client. You can see right there all the turnaround time in hours by ancillary services in a pie chart. That's just for a simple visualization, looking at like wound care versus nuclear medicine versus echocardiograms, how long the average turnaround time would be. And at the bottom, you can also see a bar chart showing the average turnaround time by hospitals for Virginia Mason Franciscan Health. And now we'll be showing our demo presentation that we will be delivering to the client. So here's our StatCom app. Basically, it's not showing.
So here's our StatCom app. Basically, when you load up the app, it has the landing page. It gives you a little bit of instructions telling you what the app is essentially going to do. Now, the only thing you can do on this page is have a drop-down. The drop-down shows all the services provided by the network of hospitals. And if I'm a medical personnel and I want to know echo, it would show me all the hospitals that offer the services, which is 9 hospitals in total. But it will also give me statistics around average turnaround time, minimum turnaround time, and max. And these are shown in hours. Now, a perfect use case would be if I want to know what nearest hospital could provide my patient the fastest possible turnaround time and results, I would send them over across the street, or if they're healthy and physically can, send them over to a different location and provide those services for them to have a speedy patient care. Another one is connecting it to a historical database to understand like historical trends, which would allow our client to understand everything about ancillary services from its inception of the data up until now.
Yeah, and to wrap up our project, we just want to highlight some of the limitations, assumptions, concerns, and recommendations. So the limitations that we encountered is that there was so much data that we were only able to run our analysis on 1 year's worth of data. So the organization in the future would need to know that they'd need to expand that if they wanted to grab up-to-date data, which they will be able to do with our deliverables. Our assumptions were the same as the limitations, is that minimal scope, and that as well as one of the major assumptions is that we just looked at the data for being the data itself. We didn't know any internal practices like domain. So for instance, like if the room distance from room to room when changing ancillary services, or there's a million other factors, but so we just looked at the data and drove analytic decision making from the data. And our final recommendation is to the organization to utilize our data to look at and make decision making processes for their future. And that'll be our presentation. Thank you very much, everybody.
Any questions? Yeah.
Yeah, HIPAA compliant. So we worked with. Oh yeah, my apologies. Yeah, so we worked in conjunction with the organization to ensure that we are being HIPAA compliant and using secure hosting of the data, for instance, and working with the organization using VPNs and all. And and then the data also that we had worked with was scrubbed of PII to ensure client privacy and adherence to HIPAA.
Yep. Any more questions? All right, well, thank you very much. Thank you. Thank you.
Team 2. Get after it. Thank you.
Hello, hello. इतना दूर पकड़ो डिस्टेंस आई थिंक दिस शुड बी फाइन हाँ आई डोंट नो there are changes the ones we have uploaded is the correct try changing try going from Power BI dashboard to this again. Just alt tab. Yeah. When when you are in slideshow, at that time we change. Put it on slideshow. Yeah. And then change. Yeah, now escape. Escape. Yeah, that's what happened. That's what happened. Why doesn't it change? Yeah. She's trying to escape. Yeah, yeah. It's happening. What did you do? Yeah, it's okay. No, not that. Are you sure? Put it on slideshow again. Now try to escape and then go back to dashboard. Yeah, escape. Exit and go to dashboard. Yeah, now that's how you'll do. Yep. Yep. You can. There should be. Yeah. Right? Ready? Hello. Yep. Good morning, everyone. I'm Harsha Chetty, and I'm the project manager for Team 2 Data Divers. On behalf of our team, I would like to welcome you all today to our team's presentation. We are grateful for having worked with Virginia Mason Franciscan Health on the project Average Cost Per Case Reduction. We have divided today's presentation into 3 parts: project overview, dashboard demo, and then we will conclude with recommendations and solutions. Let me first start off by introducing the team members to you. Team 2 comprises of Kate Cho, Sahib Kaur, Khyati Thakkar, Vasudev Shikari, and myself, Harsha Chetty. We would like to extend our sincere appreciation to the client, to project sponsor, and to Milgard CBA team members for encouraging and supporting us throughout the project. Coming to business overview, Virginia Mason and CHR Franciscan have merged recently, and collectively they perform over 40,000 surgical procedures every year at 9 surgical locations. They use over 200,000 supplies and implants every month. So given this huge amount of data, our objective was to identify the cost-saving opportunities and variations in the surgical supply cost between surgeons, locations, and procedures. So throughout the project, we have followed the CRISP-DM methodology. So it is an iterative cycle until you find the best possible solution. As you can see here, the data is at the very center of the diagram, meaning that a project can only begin when the data is available to analyze. Moving on to data sets, we received 2 types of CSV files from the client: surgical supplies data and surgical cases data, which included patient-related information for the year 2020 and 2021. Below is the list of 28 variables that we have identified as relevant for our analysis. Now let me walk you through the high-level system architecture. Starting from the extreme left, the data is stored internally in the EPIC and Lawson database. From these databases, we have extracted the data, performed some data cleaning and transformation in Python, and then uploaded it to Microsoft SQL Server. Then using Microsoft SQL Server Management Studio, we queried the data for many purposes, like building the dashboard, ad hoc query, data modeling, and reporting. Now, these are the 4 stages of business analytics that we have worked on throughout the year. Starting from descriptive and diagnostic analytics, we conducted t-test, ANOVA, hypothesis testing, and R-square analysis in Tableau, R, and Excel. Then after some exploratory data analysis, in predictive analytics, we conducted multicollinearity tests and built machine learning model in Python and Azure ML Studio. In prescriptive analytics, we conducted a cost and wastage investigation in Tableau and built many dashboards in Power BI. And finally, in cognitive analytics, we built a word cloud and natural language processing queries in Power BI. Now I would like Khyati to walk us through the live Power BI dashboard demo.
Thank you so much, Harsha. So this is the surgical cost analysis dashboard that we have prepared for Virginia Mason Franciscan Health. On the top right corner, you can see that there are 4 KPIs: median, average, minimum, and the maximum cost. These costs are represented for one type of primary procedures. For now, I have selected bypass artery coronary procedure. As making this selection, below 2 visuals, surgeon 1 and surgeon 2 will display all the surgeon names who have been performing that surgery. We can select any 2 surgeons from the given list and see all the cases performed by them during the time. Identifying what are the cases, what is their median cost, average cost, and the total cost, we can further drill down this data on the supply category and the supply types. Now let's take an example here. The average cost of this surgery is around $6,000, but I can see for the surgeon 2 named KNN, of course this data is masked, case ID 724 is costing $17,000, which is an outlier in our data that something is going way wrong in this. To identify what is the supplies category that have been used during this time, we can click on that, and supply type visual on the bottom will display all the supplies that have been used during that case. So we can see that endoscopy and the laparoscopy is costing $13,000 for this specific case ID. And this will help VMFH team to work with their surgeons and identify what and where the difference lies in their supplies. Moving on to the next, moving on to the next dashboard. We have prepared the surgical location-wise, procedure-wise, and surgeon-wise analysis. On the top, we can see how many number of cases have been performed at a surgical location, what are the different cases that have been there, like what are the different surgeries, and who are the surgeons performing those surgery. We are giving them the count of case IDs, average cost, median, total cost, and the percentage of grand total, which help them identify who are the major contributors in the surgical industry. This data is also further drilled down at date dimension. So this data can be further analyzed at quarter level, month level, and a date level. Also, the procedure level complexity and the supply types can be used to analyze this data. Moving on to the third slide. Yeah, so in this, we have prepared a manufacturer name and the supply type-wise average cost. If, let's say, I want to identify who are the suppliers or manufacturers giving me gloves, as soon as I click that, I'll be able to know who are the major contributors, and Cardinal Health in this scenario is the major provider of the gloves, and this data can further be analyzed walking through the manufacturer and identifying the cost differences. Again, this data is also drilled down at date dimension. And lastly, we have prepared natural language processing. So this is a very interesting thing we have worked on. In this, we have prepared some basic questions that can be asked by simply typing the questions. As you can see here, this is the average cost per case ID by a primary procedure. As soon as you click on these questions, the visualization will pop up. And let's say I want to identify average cost per case ID by different hospitals. So what I can simply do is click on the second visual, like second card, or either just delete the hospital and write any other dimension I want to. So it will give me the average cost or the total cost likewise. So I would like Sahib to take forward from here and explain. Thank you.
Thank you so much, Khyati. So moving on to predictive analytics, we firstly did the multicollinearity study, and after doing that, we tried multiple machine learning algorithms, such as multiple linear regression, random forest. However, we observed that we were getting the least error of 345 and highest R-squared value of 74% using the XGBoost model for regression. Now, as you can see here, these are the 24 most important features that we obtained from our best model. So as you can observe here, used and wasted, along with some other features like patient in class and monitor anesthesia, are the major cost drivers. Therefore, we decided to drill down further to analyze the waste count, because there is a huge potential to save cost by minimizing the wastages. So as you can see here in the first visual, there is an obvious direct relation between the number of cases and count of wastages. This orange line depicts the count of wastages. So there is an interesting observation here that in hospital number 2 and hospital number 3, the count of cases are similar, but the amount of wastages is very high for hospital number 3. Now that we have observed the nuances at hospital level, we can further drill down our scope to specific specialty services and patient class. So as you can observe in both these visuals, the bigger the size of the entity, the higher is the amount of wastages. Moving on to the next visual, these are the top 5 high-costing procedures, along with the name of the surgical supplies which were used in those procedures. So as you can see here, the darker the color on the scale, the more is the amount of wastages. Now, in the bottom visual, we can find out the precise name of supplies name within a supply type and along with their manufacturer information. Now, this visualization displays the trend of surgical supplies cost over the period of 2 years. So as you can see here, there are similar peaks and valleys for certain hospitals. So the client can use this historical data to prepare and manage the high volumes of transactions during specific certain months. So now these are the 4 key deliverables. The first one is the trend analysis report, which documents the findings of the exploratory data analysis. Secondly, the dashboard demonstrates the cost variation between surgeons, locations, and procedures. The prediction calculator, based on the machine learning model, helps to forecast the total cost of surgical supplies on a per case basis. Now, based on all the analysis that we have showed in this presentation, these are some of the recommendations that we made to our client. So firstly, we recommend our client to focus on the important features for monitoring the cost and exploring vendors which have the most cost-effective supplies. Now, the dashboard here will help the client to visualize the cost variations and encourage standardization of supplies. The non-technical stakeholders can use the NLP feature to seek answers to simple queries, and they can also use the word cloud feature to observe the high-costing manufacturers and their respective supplies on quarterly basis. We also recommend our client to track and minimize the wastage of high-costing supplies like heart valves and MRI sensors. Lastly, we recommend our client to use predictive model to determine the optimal inventory levels by forecasting and planning the budget while meeting the demand. So this concludes our presentation. Thank you so much for your time. Any questions? So our client wanted us to analyze the variation in total cost of surgical supplies, and because there are like many factors that impact that total cost. So that's why we defined primary procedure as a specific criteria on the basis of which we used to analyze our cost. So just to give you an example, if there are 2 surgeons and both are performing same type of primary procedure, then we can analyze their cost, because now the comparison is apples to apples. So that's why taking the primary procedure was important in this case. The primary procedure being performed on the patient, and the surgeon is performing that procedure. So that's how, if that answers your question.
And again, there are not more secondary procedures they apply.
Yeah, so this is basically only a primary procedure, what every location would be conducting, and different surgeons who are performing that specific procedure at a different location, and we are comparing those 2 procedures for those surgeons. I hope that made sense to you. Okay, yeah. So, yes? Yes?
This is what? Did you like cross-validate with the domain experts that this is what they're looking at?
Yeah, of course.
Can you summarize the question briefly so that the folks who are watching
Okay. Yeah, so the question was asked like wasted count that we are displaying here for each of the procedures. Was that in consideration with the clients, cross-validated with the clients? To answer to that question is yes. So whenever any surgery is performed, there are multiple supplies that have been pre-ordered. Some of the supplies are used during the surgery, some of them are just kept in the inventory, and some of the supplies are wasted. There are some supplies that can be reposable as well, like let's say I'm ordering a gown or something like mask. If the packet is coming like 100 bunch of supplies for in that specific packet, the cost of that will be divided by 100 supplies that actually are there in that. So such type of consideration are there, taken in consideration with the client expertise.
The things that are used, right? It's actual wastage.
Yes, it's the actual wastage, not used.
So for every procedure performed, we have some specific number of wastages in that procedure and some specific number of used supplies in that procedure. So that's how we differentiate between both of them.
Find out what's the cost of each procedure or how much supply each surgeon spend. So what can you do with that information?
So
if you are a CEO of the hospital or the chief medical officer, what can you do with it?
yeah, so
Generate more bigger thing.
right.
So actually, the main problem for them was that they have such huge data, and they didn't have the main tool to visualize the data in the first place. So what we have given them is, it's just a first step towards the right direction, that at least they'll start visualizing the data, identify the variation between the surgeon, like you saw, right? One surgeon is costing just 4,000 for same procedure and other is 17,000. So if they start by identifying these huge variations, they can go back to these surgeons, talk to them, like what kind of supplies are you guys using, and standardize all the supplies between the surgeons. So I think this is the next step for the client that we have recommended.
Yeah, this is like a basic preference card we are creating for certain type of recipe or certain type of procedure, that these are the supplies that needs to be used, and this is the ideal list of supplies and their cost.
And surgeons in particular are a notoriously fickle bunch.
Yes.
They don't like being told to do a lot, especially non-surgeons telling them how to do surgery better.
Right.
So I think because I was going to ask very much the same question. You've done the technical work, right? That's the IQ side of it. How do you swing the pendulum over to the EQ side and actually start to impart some of the change management? Because the chief medical officer might have an MD and an MBA. There happens to be one of those floating around in our town.
MBA, there are a lot of MBAs.
I know, and they're a dime a dozen, right? However, if you can convince that person to come up with a strategy on how am I going to sit down with these surgeons, take the top 5 surgeons in the study, and going in and saying, why are you wasting so much? Probably not going to go anywhere, right? But like, are things breaking? Do we need to find better supplies for you to do, to do the job? That would be a very interesting conversation to have as far as what would be the strategy around change management.
Yeah. So when the client came to us, and their main goal was to get a dashboard that can be presented to steering committee. So this committee, after the merge of Virginia Mason and CHI Franciscan, their main goal was, we want cost-saving opportunities, just identify and give it to us. So when you say the dollar value to the steering committee, they will take some actions. I mean, obviously, if we say, they won't listen. But at least the higher level executives, when they present these kind of dashboards with the dollar amount that you're going to save, then there will be some change management initiated in the hospital. Yeah, it will take time, but it will definitely happen.
Overnight, yeah, of course. But with the data can be, data can speak. Yeah. Any other questions?
No, that was terrific.
Thank you so much.
Nice job. So how does it feel to be in person? This is good. And so I've got a schedule, I've got times, I've got a clock, I've got all this, but I'm having too much fun, right? Being in a room and asking people questions in person. So we may run late, but let's keep the energy, right? And I will reduce my information session to a fraction to eat into that so we can have more of this. This is great. Team 3, let's get after it.
You have to change that one. This one. Oh, okay. No. Courage? Oh, yep. Is okay? Whenever you guys are ready. Good morning, everyone, and thank you so much for joining us today. This is Team 3 presentation, and our client is City of Palo. My name is Ali, and today I will be presenting with all of my team members here. This is our 4 team members, John, Ella, Ali, and Carmen. We have been working together during the past 12 months for this project. Quickly, we would like to say thank you so much to our analytical teams. Actually, they provide us for incredible support and helpful guideline for this project. And in addition, this project cannot be happened without the timeline guideline with our project sponsor. And therefore, thank you so much for all of you for providing time and working with us today. We can broken this project to 4 phases. Phase 1 actually related to the discover plan. We did market and organization analytics, and we defined the problem for the City of Palo. In phase 2, we did data gathering, and in addition, we did the data cleaning as well. In phase 3, we deploy our project, and actually we did the predictive and prescriptive analytics for our project. And in the last phase, phase 4, we finalize our project and analyze our funding for this project. Our scope in this project divided to 4 phases, to 4 parts. Tax revenue analytics to identify the growth sectors in City of Palo. And the second scope related to the economic impact on the sales tax revenue for the City of Palo after the pandemic. And the next one, the forecasting of futures sales tax revenue. And the last one related to the examining the city related to demographic in the City of Palo. Next slide, please. All deliverable to this project related to divided to 3 parts. Part 1, City of Palo growth dashboard. Actually, the objective of this deliverable related to figure out what is the historical of the sales tax growth in the City of Palo. For that purpose, we use that Tableau. Second, deliverable related to time series forecasting machine learning model. And for that reason, we use that program R in order to figure out what is the tax forecasting for the future of the City of Palo. And the last one related to the social media for analyzing the Twitter data. Actually, for that part, we use that the Python in order to figure out what is the city of value. Next slide, please. Our accomplishment for this project related to data collecting and the data cleaning. The next one related to the data analytics plan. And the next one, we did a descriptive and predictive analytics. And we did that, the benchmark for the other cities. In order to doing the benchmark, actually, we try to contact with the other cities, other 5 big cities in the Washington state. Those cities were Tacoma, Everett, Bellevue, Spokane, and in order to asking a question about that, what they did about that, the passing for the after the COVID pandemic. Okay, right now I'm just passing to Ella for doing this. Thank you.
Yeah. As a part of descriptive analytics, we collected the census data for the past 10 years, and we created a Tableau dashboard to visualize some of the key demographic informations like home income, poverty, and industry and occupation details, and commute distance. So we tried to compare the recent census data with the demographics for the past 10 years. Unfortunately, the census 2020 data has not yet been released. So we had a wide picture about what the city is about. This is our part of descriptive analytics. Next. Yeah, as a part of diagnostic analytics, we collected our sales tax revenue data from the Washington State Finance Department from the year 2012 to up till date. And we can see the sample of dashboard is there. Once analyzing our sales tax revenue data, we understood that 75% of the revenue comes from the retail trade, and followed by 10% of the revenue comes from the construction sector, followed by 9% of revenue comes from the food and accommodation sector. From the graph, it is visual. We could see a drop in the sales tax revenue received in the year 2021. It's decreased by minus 3.6% compared to the previous year. Next slide, please. Yeah, as a part of diagnostic analytics, so we wanted to identify the impact of the pandemic on our sales tax revenue for the city. So we identifying what are the opportunities this pandemic created for the city's revenue. So we identified some of the sectors which have been performing well during the pandemic, but it didn't perform well before. So these are some of the sectors like local deliveries, telemarketing, e-commerce, and direct title insurance carriers. And the sectors which got impacted, which would be performing well before, but not performed well during the pandemic, are like construction, food accommodation, and education sector. Next slide, please. So yeah, as a part of predictive analytics, we use time series forecasting techniques to predict the future sales tax revenue for the city. We performed this analytics in our platform. So we collected that data for the past 10 years, and we did some pre-processing, like finding the outliers, removing those outliers, and we visualized some of the trends. We could see the increasing trend and seasonality in our data, and we conducted some hypothesis testing like augmented Dickey-Fuller test, KPSS test for stationarity, which is essential for building a time series model. And we built different models like naive Bayes, exponential smoothing method, neural network, and ARIMA model. We used RMSE as our evaluation metric to choose the best model, and we picked our best model as an ARIMA. Next slide, please. We didn't stop here. We continued our research. We reached out to similar cities to find out what are the other variables they were including in their model. Because in our ARIMA model, we are predicting the future sales tax revenue based on the past data. We don't have any other input variables. So we identified this Arimax model would be a best solution for our sales tax revenue data. We use the macroeconomic variables like inflation rate and unemployment rate. And so we use these as an X variables. This is the ARIMA extension of ARIMA. The X is added to the X stands for the exogenous. So we use these X variables to predict the future sales tax revenue. And we got a better results in terms of our accuracy with this Arimax model. And we conclude this is our best model. Next slide, and I'm passing over to John for prescriptive analytics.
Okay, so I'm just going to quickly summarize the stuff we did in Python. So the main thing we found was a focus on safety, community, and internal small business. The city of Puyallup is very focused externally on showing that they are trying to grow their inner city. They're trying to grow from an aspect of farmers markets, and as you can see here, some of the word cloud stuff we found, emergency preparedness, focusing on the city of Puyallup proud, also their schools, masking up, and COVID preparedness. Go to the next slide. So also the Washington State Fair is located there, Puyallup PD, but also this emphasizes safety as well. Also the overall sentiment analysis that they portray online via social media is overall very positive, and they have a good presence as well there. So next slide. Go ahead and pass this.
So we looked at the related city analysis. As Ali said, we reached out to other cities in Washington, and some of the ones that got back to us was Gig Harbor, Tacoma, Auburn, Bothell, and Brampton. So we looked and compared the data as a pandemic, and then closely we saw Auburn was closely related to city of Puyallup. And then some of the strengths and focus areas that we looked at, Puyallup is very heavy on retail, and then downtown corridor, and then focus on smaller businesses, and the focus on safety, as John earlier mentioned. Next slide. And some of our concerns were, one main concern was that the city of Puyallup lacked data. They got their data from third-party sources like Census.gov and Washington Department of Revenue. And then also we still didn't have Census 2020 data, so we couldn't really compare the impacts going forward. Next slide. And then our future research would be to get that 2020 census data and see how it impacted, and then compare it with our current data. And then also we would collect geolocation and model data to provide insights on local businesses. And then lastly, go in depth on social media, seeing platforms like Google and Facebook and creating a visual for them as well. And then thank you for everyone. Do you guys have any questions?
Like when you're doing the time series analysis, like you're checking for the seasonality and everything, right? So randomness. Did you find that during the COVID period, could you find any trends or randomness in the data?
Yeah, we do had okay. So the question is, while doing the time series analysis, we do include the data from during the COVID pandemic, right? Yeah. We included COVID data from the 2020 and 2021 as well. And yeah, we could see some increasing trend and seasonality, and there is definitely noise. And we do have one test called Chow test. So yeah, the test is to predict if there is any historical event or due to like a war, or whether it has an impact on your data. So we did the test and found in a particular point, I remember it's like November 2020 November, when we test that hypothesis testing, the p-value drops below the 0.05. It proves there is a structural break in the data set. Yeah, we do have an impact there. Yes.
You mentioned that they didn't have their own data, right? They had to pull in from various, various third parties. Was there any conversation about setting up data architecture for them to ingest that on a regular basis and start to compile and hit their, not their own data, but basically make it easier for them to do subsequent analysis?
Yeah, so with regards to them gathering their own data and then them also now taking this data and better utilizing it themselves, yes, that was one of the things that they're aware of. They're very well aware of that. Typical government data, yes, it is all spreadsheets and it is disparate places, and so finding the data even within the city, a lot of it she didn't know the contact for. And so we got in contact with a lot of people that provided a lot of dead ends for us.
Yeah, to add on, they are still using forecasting using spreadsheet.
Great job, team. Okay, team 4.
Hello. All right. Hello, everyone. We are Team 4, and today our project is Given Kind. So let me start by introducing myself. Hi, my name is Akanksha.
Hi, my name is Emily. Annika.
And I'm Charu. So for our client representatives, we have Laura, who is the founder and CEO of the organization. We have Andy, who is the VP of engineering. We have Catherine, who is the head of operations. The UW MSBA team has been working in close proximity with all of these 3 contacts over the last year. So I'll start by giving a high-level overview of what this organization is and what they do. So imagine, Dr. Haluk, you lost your pencil, and let's imagine that this is a challenging moment in your life. So perhaps friends, family, students, coworkers would like to help you out, but they don't know how to exactly. So that is when Given Kind comes in, where where help is not just limited to offering cards or greetings or flowers, but is expanded to more tangible services like arrangement of meals, transportation, pet care, etc. So Laura, who is the founder of Given Kind, she and her husband, they both started this company after experiencing a sort of a traumatic loss in their family, and they realized that there is a need of a space that works as a help coordinating platform so that friends, family, well-wishers have a space where everyone can offer help from anywhere and with any means. So this is how Given Kind was born, and over the years, the organization has gathered a lot of data around support, demographics, user behavior, and their intention for us, the UW MSBA team, was to use these business insights to boost their business growth, expand on their collaborative partnerships, and also enhance their user experience. So moving on, so after identifying the high-level goals, high-level business requirements, we came up with high-level goals and objectives for our project. So first, we will be delivering a KPI dashboard that consists of weekly and monthly internal Given Kind data. It'll also be based off a product purchase analysis that we conducted in phase 2. The second deliverable will be a marketing dashboard, which will be based off a calendar claim analysis that we did in phase 3, and also the internal Given Kind data. The third will be a partnership dashboard, and this will be based off external data sources. This will be especially for the organization to collaborate with different other outside organizations, especially in the time of crises. The fourth will be a delivery of results on the sentiment analysis that we conducted on the organization's chat support data. So this is the image on the screen displays the final data solution for our data flow. Pretty straightforward. All of the data, or all of the user analytics data, was located in the Azure production site, where we would access it via SQL, which is a platform that the organization uses. We reflected all of this data on UW Azure database from phase 1 to 3, and then integrated with the different platforms that we were working on. However, in phase 4, we were able to directly use the SQL data through Google Sheets and use it to achieve our business objectives. The process for user acquisition traffic and external data sources was for it to be seamlessly integrated with the different platforms that we were working on. So I'll start by demoing the KPI dashboard. As mentioned earlier, for our first deliverable, we have a comprehensive KPI dashboard that presents both descriptive and diagnostic analytics, which involves internal Given Kind data. It displays 3 important businesses KPIs, which are user metrics, purchase support, and acts of service. For this dashboard, we have digitalized insights that analyze the user's monthly activity. The goal with visualizing these metrics is for the stakeholders to identify the key user and geographic demographics to take informative operational decisions. For the user metrics, in addition to the digitalized insights, we also, they're able to see where these situations are prevalent. Perhaps this will help the stakeholders improve their user experience and also expand on their collaborative partnerships. What also makes this a transformative deliverable important is that this kind of automated digitalized insights is collaborated with geographic locations was not available for the organization in the past, but after this project, it will be available for their use. Moving on, Charu will take over. Thank you. One second.
It's there, right? Yeah. Okay. So our next deliverable was marketing dashboard. We created this dashboard using Google Analytics data and given kind internal data. It basically tells the performance of marketing campaigns that given kind launches and user activity on given kind website. Okay. The first tile over here tells how the campaigns are performing in last 28 days. So this one performed really well in the market, but the marketing team needs to give more focus to the last 3 campaigns over here. The second tile is for evaluating performance of calendar claim campaigns. So calendar claim campaigns, it's a type of marketing campaign, and we created a different visualization for this one because it's currently the major focus for Given Kind. It shows the popular campaigns are the meal train with highest number of clicks in last 28 days. This validates our calendar claim analysis discussed in the beginning, which tells that most of the successful calendar campaigns have meal train requests. And a strong visual correlation can be seen between these 2 graphs, where we can see the most requests raised in last 1 month are the requests for dinner. So these campaigns are really important to Given Kind because with the high success of campaign, the user will get more support. And now for any marketing dashboard, it is important to see that it should be able to tell what is the source of the user traffic. Over here in this pie chart, we can see how the users are being directed to the Given Kind website, and almost 60% of the users came from social media. Almost 22,000 new users came from social media from in last 1 month. So that's why we dived in more into the social media stats, and we looked that Twitter and Facebook brought like most business to Given Kind in last 1 month. Given Kind can potentially increase their marketing campaigns on Twitter and Facebook so that they can have more user traffic coming forward. Over here, these are the metrics that show page views and user metrics. And it is also important for the marketing team as they can be used to measure success of the pages and make strategic decisions based on the trends. So that's about the marketing dashboard. Moving towards the partnership dashboard. So our partnership dashboard basically tells Given Kind to how they can make potential collaborations with different industries like healthcare or maybe religious organizations, public services, etc. We created 5 dashboards for this deliverable, and we'll be discussing 2 of them today. Okay, yeah, so this one is for the mega churches. This dashboard shows the links and the websites of different mega churches located in the United States, Canada, and across globally. This could be a beneficial collaboration for Given Kind because the giving stats for mega churches are really high. Our next partnership dashboard is about the Federal Emergency Management Agency, which has the official website for FEMA, and it tells the current disasters and crises going on in the United States. Through this, they can target those regions, and they can help the people who are in crisis in those areas. So business had this question when they came to us, how they can reference to outside industries that would be valuable for them. So using this partnership dashboard, they can decide their potential collaborations that could be useful for their business growth. Our last piece of analysis would be the sentiment analysis that we did this quarter. What we did here was we used given kind chat support data to analyze customer sentiments, and we extracted the chats with negative sentiment. We used dictionary method using Python, and we created we calculated the sentiments for all conversations, and we just used the negative conversations so that given kind can reach back to their customers with some kind of promotions or something like that, so to increase the customer satisfaction. Our results here showed that no chat had a sentiment below -0.5. That tells that customer satisfaction rate was high for given kind. And we also created a word cloud over here, which tells that the most of the issues were raised around the gift card and calendar services of given kind. Moving forward. So these are some recommendations based on our analysis that we did throughout this project. Using the KPI board that Akanksha just discussed, given kind could potentially focus on low-income zip code areas to provide organizers with more resources to create more marketing campaigns that totally focus on those zip code areas. They could also partner with firms generating high revenue through gift cards. So during our product purchase analysis, we saw that DoorDash was generating like most revenue through gift cards. So that could be a potential collaboration for given kind to expand their business and to increase support. Using marketing dashboard, if they create their campaigns over Twitter and Facebook more, that would bring more clients to given kind, more users to given kind. And they could also recommend organizers to add meal trains in their calendar for better engagement. With partnership dashboard, as I just discussed, they can collaborate with many organizations out there, like fire administration, mega churches. We also did analysis for veterans' healthcare data. So making collaborations with them could potentially expand their business growth. And finally, with the sentiment analysis, if they find some really high negative conversations during the analysis, they could reach back to those customers with some kind of promotions or to increase the customer satisfaction rate, basically. So that's all we had. And we are open for questions and comments. Thank you. No questions? Thank you.
Welcome to the presentation of Team 5. My name's Harman Singh, and our client is Hey Kiddo. My business analytics team, we have Natasha, Monikuntla, Akshay, and myself, and we rotated roles each quarter. This is our client. We like to thank Dr. Nicole, Dr. Kayla, Matt, and the whole team of Hey Kiddo for giving us this great opportunity to work with them. This is the Center for Business Analytics team, and we would like to thank the MSBA faculty and staff for all the help. So a little bit about Hey Kiddo. Hey Kiddo is a startup founded in 2020, and they're doing something very unique. They're empowering parents, caretakers, and educators with the tools necessary to help children ages 5 through 11 build social and emotional learning skills. And this is done through their various products, which are backed by psychologists and educators. And they do this through a web platform and an app platform, and the app platform is coming out very soon. They're doing beta testing, and all this is backed by science. So the way they do this is you have social emotional learning assessments, which the parents take based on their children, and these assessments provide them with feedbacks and solutions. So our goal was to develop a classification algorithm that accurately segments users, which are parents and caregivers, into specific categories based on these assessments. And the objectives were that we wanted to develop an algorithm that collects and segments data on social and emotional deficits. And we also provided them with like a template for collecting data that is secure and efficiently, since this is data on child's mental health. We also wanted to develop a way to red flag scenarios based on the diagnoses. So let's just say they fill out that assessment and there is something wrong with the child's mental illness and requires an immediate intervention to help them as much as we can, and that will be red flagged so the Hey Kiddo team can provide the necessary resources and directions. I'm going to hand it over to Natisha for the next part.
Good morning, everyone. So, so far we have had scenarios where we had data and we have performed analysis. We had an interesting scenario considering that a client was launching their app and it's an app launching phase. What we have done here is Hey Kiddo has conducted survey on different parents and caregivers to understand the background of the users there. So based on the survey analysis, we have extensively researched an external data set which resonates with the scope and objective of Hey Kiddo here. We have performed descriptive, diagnostic, predictive, and prescriptive analytics on the external data set, which we have collected from a non-profit organization. And based on that, we have deployed a predictive model, and we have created a prototype out of the external data set, which could be used by Hey Kiddo once their app is being launched full-fledged. So this is the survey analysis, what we have performed here to understand what will be the major metrics to consider when they are launching their application. So there you can see a word cloud there, which has different scenarios wherein they can red flag the scenarios or what are the important metrics which goes into mental health issues of children. And we have ranked the behavioral analysis also here, which are important for the application. So this is being used for the beta phase of the application. This survey analysis is being used for that. Next slide, please. So based on the analysis what we have performed, so we have categorized our external data set attributes into different verticals. Next slide, please. And we have, after categorizing the attributes into different verticals, we have analyzed more information about it by performing the descriptive analytics here to understand the demographics of the survey respondents. Here we can see that most number of respondents are from United States, and most of them are in between the age group of 26 to 35. Next slide, please. And here we have tried understanding the behavioral pattern of the users who have taken the survey. Here if you can see, it's pretty evident that people are more willing to discuss about their mental health issues with a supervisor rather than with the co-workers. And in the second part of it, you can see that people are more willing to discuss about their physical health than the mental health condition in the behavioral analysis. Next slide, please. And we have created another frame which talks about the resources which are available for the mental health illness or for mental health wellness. So most of the employers, they do provide mental health benefits, and the employers are aware of it, and the employees are also aware of it. But on the contrary to that, if you see here, most of them, they are not willing to discuss
the options which are available for the mental health condition rather than the physical health condition here. I'll hand it over to Moni for the next part of the presentation.
Thank you, Nitisha. So we have built a predictive model based on a mental health survey dataset taken on the tech industry. Now, in the predictive model, we are trying to predict whether the survey respondent has taken mental health treatment or not. The idea of using this, this particular data set is, and how HeiKido can use it in their scenario is, just like this mental health data set will predict whether the person has taken mental health treatment or not, HeiKido can similarly use their own data set to predict if the child has any deficit behavior or any kind of behavior which requires intervention or not. So here in the correlation matrix, we are trying to identify if there is any linear relationship between the variables used in the mental health data set. However, we see that there is no strong correlation between any of the variables, but we are not using country and state because there are very few variables in those two columns, and we are also not using the comments feature because there are a number of open-ended responses which will not provide any conclusive result for the model. Next slide, please. We have also done principal component analysis to explore if we can reduce the number of dimensions in our data set. And as it is evident from the cumulative variance graph, reducing the number of dimensions will not help in our case since we will require all the 23 components to build a proper, robust predictive model. Next slide, please. Here we can see all the different predictive models that we have tested to find out which will be the most accurate model. The CV score represents cross-validated accuracy scores for all the models. Mean score is nothing but the average of all the cross-validated scores. Standard deviation score shows how all the different cross-validated accuracy scores vary from their average score, and recall score is nothing but the true positive score. Now, I want to highlight the importance of the accuracy and recall score in here because accuracy score shows how many of your predicted values are actually true. And recall score is another very important metric in medical sciences because you want to be able to correctly predict predict the true cases from the actual true cases. And here we can see that logistic regression and support vector machines have the highest accuracy scores. But for the purpose of this, for this data set, we will be using logistic regression since it's a binary predicted variable, and majority of the variables used in the data set are categorical in nature. Next slide, please. So we have we have used the logistic regression model to build the final model. And after building the final model, we can see the most important most significant variables which will help us to build the most correct model. And those variables which will help in building that correct model include gender, family history, work interference, number of employees, whether they belong to a tech company, whether they have benefits from the company, and whether they have observed any consequences for discussing their mental health issues with their coworkers. And I would now request Akshay to take on the presentation from here on.
Thanks, Moni. So once we had the most parsimonious model built in Python, we also wanted to test the results out on Azure Machine Learning. So this is the build on Azure Machine Learning. And we started out with all the variables in our data set. But as you know, the bias variance trade-off, we had to arrive at the key set of variables which could explain most of the variance. And we used permutation feature importance build for that. And we came up with a list of 8 to 9 variables which are the most important ones. Next slide. Yeah, so we also wanted to understand the ROC-AUC curve, which is receiver operating characteristics and area under the curve. So this is particularly important in the mental health data set because as we know, the data set is an imbalanced data set where there won't be as many positives as negatives in the data set. So we wanted to understand if we change the threshold from 0.5 to 0.8, how does the model performance change? And on the left chart, the closer your curve is to the top left corner, the better performance of the model in this sensitivity and specificity chart. We also wanted to understand the precision recall chart because precision tells you how many true positives are there out of the total positives that you have predicted. And recall will tell you how many true positives are there out of the actual total positives in your case. Accuracy might skew the numbers in this imbalanced data set. So we also wanted to look at the precision recall variables, and you can see the precision recall numbers below. We also looked at F1 score, which sort of summarizes the precision and recall in our data, which is the harmonic mean of precision and recall. Once we had the final model built, we also wanted to look at some prescriptive data. This word cloud in Tableau, it will help HeiKido to understand all the comments that comes from the users, especially in their beta launch phase, where this would tell the sentiment of the early adopters that they have. We also wanted to look at how our model is performing based on the different variables that we had in the data. So here we looked at the spread of predicted versus the actual numbers for all the different variables we had and how the split was working. Finally, once we had the most parsimonious model, we also wanted to understand how to deploy it and share it with Haikido. So here we have a sample row which was populated, and the scored probability would tell whether a person requires mental health treatment or not. Now they could use this sample, or they could also run a batch file with all the users for a week once they run the model, and then it will give them the scored probability for the entire data set. Now, we also shared some recommendations with them, and these are some of the sample insights that we shared. First of all, type of employment, whether a person is self-employed or not, does not matter a lot whether the person is seeking mental health treatment or not. Family history, however, does play a crucial role in determining that. Availability of resources at an organization also plays a crucial role. And then along with the resources, awareness amongst the employees of all the resources that are available at a workplace is also crucial. Finally, we also shared the following deliverables with them. So we had the deployed model that we created on Python as well as Azure ML. We also created the cognitive solution, as we saw, in form of word cloud and the deployed model. We also performed a lot of data visualization on the survey data, on our final data, on the external data, to help them throughout the survey phase, to the beta launch phase, to our modeling phase. And we also shared a data management plan with the team that will help them aid understanding their entire data pipeline once they have the model built and how the users are adopting to their app. So that sums up our presentation. Thank you for listening. Thank you. If there are any questions.
I have a question. So how do you account for the precision recall trade-off? So if you have high recall, some kids, it accounts for the model predicts some of the kids might have the disease, but the real case kids might not have the disease, but they have been fought to the risk protocol. So how do you account for those data?
So the question is, how do you account for the precision recall trade-off? So in this case, it is important, while it is important to accurately predict the true users, the true positive users who require mental health treatment, you also need to understand if the model that you're predicting is being helpful in highlighting all the positive cases, as well as comparing it to the actual positive cases. So the ROC, the receiver operating characteristics curve, area under the curve, and the precision recall chart will help you understand whether the right balance is. So what we did was, we also looked at some hyperparameter tuning and some of these features, some feature tuning, to understand which is the best model to arrive at for the precision and recall trade-off. Yes. It is extremely crucial in this case. Any other questions? All right, thank you.
All right. Our next client is our very own UW Tacoma. Team 6, come on up and we'll hear about student retention.
Good morning, everyone. Thank you so much for being here.
I'm Subodh Khandelwal, representing Team 6, and I have my colleagues Vaishnavi Shankar and Anjali Koshar, who have been working closely with the institutional research team of UW Tacoma on the student retention and attrition problem. So before, next. I'm sorry. Icons got hanged or something. It's changing there. Sorry about the technical delay. So before I begin, I'd like to actually thank our clients for giving us this opportunity to work on the project. Joe Lawless, Alice Few, and Andrew Chamberlain, thank you for your support. You always helped us throughout the project. And of course, Center of Business Analytics team, Professor Haluk, Michael Alser, and Murphy. So you've actually given us, always backed us whenever we need it. And lastly, all our professors and instructors, without the knowledge, we would have been able to do this project. Thank you so much, everyone. Okay, go behind. Yeah. So our client actually doesn't need any introduction. You all are in the client office. But however, I'd like to highlight the vision of UW Tacoma. The vision is to educate a diverse student body to become global citizens, responsible citizens. What's happening today, we all know. So we need to be responsible citizens and future leaders. Next. So UW has been facing this problem for some time. They've actually seen a lot of attrition in students. Students are not been completing the graduation and dropping out. And our last few years also, they've seen few enrollments. I mean, there's a decline in the new enrollments as well. So because of the time factor, our scope was actually narrowed down to predicting the at-risk students. Who are the students who could be the possible dropouts in the undergraduate with STEM majors. And we had to prepare an analytical solution to understand if there are any ways where UW could actually increase the retention rate. Next. So because the data was very confidential, we had to access the data on the UW servers, and we use a SQL server on the server on the UW servers, and we had extracted data from 30 different tables. We created one consolidated table for our what we needed for our analysis, and we used 5 years data, last 5 years data. So what we've done is, as a part of the solution, we've actually put it into 3 different parts. One is understanding the student demographics through the dashboards, through Tableau, and then predicting at-risk students using the machine learning algorithms, and lastly, preparing a cognitive solution through Power Apps. Next. So our project was divided into 4 phases. Phase 1 was requirement gathering. We had to undergo the FERPA training because of the data, sensitive data. Second phase was more on descriptive diagnostic analytics, where we were actually exploring the data that we had got. What are the different, where is the data and how we need to explore it further. And third phase was more on predictive analytics, where we used different models, machine learning models, and we finalized on the logistic regression through through which we could identify the at-risk students and what are the factors that are affecting the students' attrition. And last, we built a cognitive solution, the student survey on the Power Apps. Next. So descriptive and diagnostic, I'd ask Vaishnavi to take over.
Thanks, Subodh. For the next phase of our project, we performed descriptive and diagnostic analysis in Tableau. So for the first, we wanted to see what's happening with student attrition. Like, for example, if we look at the histogram here, we see maximum attrition of students between 0 to 4 and 6 to 8 quarters. So that tells us that there is an early intervention needed to see what's happening with the students and take some corrective measures. And also we see very evidently the transfer student year over year have shown maximum attrition. So this is the entry group which need much more attention to increase their retention and decrease the attrition of students. We also see a causality between the number of the average graduation rate and GPA, but this does not collinearly tell that this is responsible for the attrition. The next analysis is about the majors. We see that computer science and information science have maximum number of students graduating. For example, if we take biomedical sciences, we have 201 students graduating, but that is only accounting to 58% of graduation rate. And year over year, we see for biomedical sciences, the graduation rate has been ranging from 54% to 66%. So an increase in graduation rate will uptick the number of students retained. So these are the majors that need a little bit of more attention. For the next phase of our project, we performed predictive analytics, and for this we used a regression technique called logistic regression. This included connecting our data from Microsoft SQL Server with RStudio, and we performed imputation of data, created some new categories of data to see where is the shift happening. After performing all the data cleaning steps, we went ahead and arrived at our best model. And our model is predicting the students who are at risk at an accuracy of 89%. And very specifically, we see a specificity of 94%, which tells us that our model is predicting the zeros, which are the students who didn't graduate at a 94% accuracy. Here is a small representation of our confusion matrix. And our area under the curve was 91%, which tells us we have a little bit of leverage to increase our accuracy to correctly classify the students. Because in academia, it's important to reduce the misclassification. A student who is about to graduate don't want to be classified as you're not going to graduate. So this gives us that leverage. I'd like to hand it over to Subodh to briefly walk us through how we arrived at our cognitive solution.
Thanks, Vaishnavi. So quickly, I'll run you through this flow chart, which is basically how the information flows from the student to the university and back to the student. So what we thought is that there are all the other factors are known factors which we have seen, but there are many unknown factors which also contribute to the attrition of students, right? So how do we get those? How do we get that data? So we created a flow chart where there'll be a survey which will be, we've tried to integrate it with Canvas or MyUW. So when a student logs in to Canvas or MyUW, the student survey will open up, and it'll be a short survey, probably a cyclic one, so it could be either once or twice a month, where we shall have just questions that will be categorized. Predefined categories are there, so it could be academic, food and housing, mental well-being, mentorship, or whatever help people, the students need. So once the student responds to the survey, it'll be stored in the database, and then it'll be categorized as to whether the student is at risk or he's not at risk, depending on the response that he gives. If the student is at risk, then there will be a task force which we have recommended to be formed, and the task force creates an action plan to address the students, to go back to the student and figure out what the error is, what the problem is, and whether it can be addressed or no. So we can take proactive action in order to, to understand the sentiments of students before rather than later. And I'd like Anjali to continue with the demo of the Power App.
Thank you, Subodh, and good morning, everybody. Coming to the cognitive solution, we have made a Power App. This Power App consists of few questions, and this is a small demo for Power App. We have added few demo questions. We haven't added questions according to categories. This is our suggestion, and we have been in terms with our client also to deploy this on Canvas app, so we can get every student can access it easily, and we can gather the data, and we can do sentiment analysis on it later on. And this is the sample question. The question number 3 says if a student is in a need of a technical resource. Fourth one is about the major, so we can focus on the major where students are unhappy. And the fifth one is any other specific comment that students want to submit. Yeah. Coming to recommendations, we have to encourage more and more students to fill this survey, so we have more and more data to do analysis on. And we need to make the survey according to the categories or domain. We in the end will suggest to have a buddy system or a mentorship system. Coming to the conclusion, we hope the survey will help to gather data for students, and it will help the UW to increase the retention rate. Thank you.
Hi, I'm wondering if there's any way to connect the Power App survey to the data, so you don't have to ask those demographic questions. You might get higher response rates if students don't have to spend a bunch of time in data we already have about them.
Yeah, we've been talking to Sean at the UW Seattle campus, who's in charge of the LMS, and we're trying to figure out if it can be integrated with UW, my UW, or with Canvas. So once a student logs in, you don't need to take the initial questions. It'll be actually integrated with that. That's what we're trying to do. Any questions?
Thanks, Bani and Joe, for coming. Yeah.
All right. Nice job.
Good morning, everybody. Thank you so much for being here. My name is Marion, and we are Team 7. We want to start off by thanking you for being here, whether you're online or in person. This is our team. We have Teja, Shalini, Shopi, and Shafali. We also want to take a moment to thank our amazing client, Sound Credit Union, specifically Mr. Troy Gary and Mr. Jason McDougall, who is actually here today, so thank you so much for being here. We also want to thank their BI team for giving us the opportunity to work on this project. And also the CBA team, the MSBA team, the staff and the faculty at Milgard have been super supportive. Thank you for getting us through this program and through this project. So we're going to talk about, obviously, our project. We're going to talk about our tools, timelines, our models, and our recommendations. Next slide. So a little bit of a background of credit unions. Sound Credit Union is one of the largest in Washington State. Credit unions work very differently to banks. They are prioritizing members. Any productivity that they get goes back to their members, not to stakeholders. It is worth noting that it can cost up to $300 or more to acquire brand new members. And in order to get any kind of profitability, a credit union needs to retain those members for at least 2 years. So as you can see, churning members is a bit of an issue. So this is where our amazing team gets to come in. We get to build a model and build a prototype that will predict whether members are going to churn based on previous members' data. So I will pass it off to Shalini.
Thank you, Marion. So our main objective was to understand and extract the customer patterns and build a predictive model for our client ICU so that they'll be able to predict the potential churn members in future. So coming to the timeline, in the first quarter, we were morely concentrating on understanding the data and how to combine the data, and we are making an effective plan. So based upon the plan, in the second quarter, we have made some predictive analysis, diagnostic and prescriptive analysis. So based upon the insights, we have developed a baseline model, and we have also done some feature engineering and feature extraction methods to make it more efficient. In the fourth quarter, we have done some initial testing and then hyper-tuned the model by tweaking the parameters of the algorithm. So coming to the tools, we have used Power BI, we have used Tableau for visualization purpose, and machine learning to build the predictive models. And we've used SQL for storing and extracting the data from the databases. So I'll have Shilpi to speak more about the data and the preparation modeling steps. Thank you.
Thanks, Shalini. Good morning, everybody. So for any data analytics project to succeed, one of the most important thing is to have the right data and the right amount of data. So thanks to our client, we had both. We had 150 gigabytes of data in 19 files, and it covered customer feedback in quantitative form and transaction behavior, what kind of product, what kind of services the members have, and so we have abundance. So the next step was to decide what kind of model we are building. So we decided to build 2 models, one for savings and one for loans. So what we did with the 19 files, big data files we had, we segregated them in 2 main categories, savings and loans, and we built 2 models. Next slide, please. So this is a broad view of the process we have followed from data gathering, that side, to deployment. And so the 2 data sets I just spoke about loans and savings, what we did, we divided them into 3 parts, training, validation, and test. The training and validation data set were used for this cycle process. So data pre-processing, data extraction, feature engineering, and selecting the right model, hyper-tuning the parameter of the model. And once we had our final model in our hand, we used the third part, the test data set, to evaluate its performance. And to find for model performance, we not only looked into accuracy, but we looked into precision and recall as well. And finally, for deployment, we used Azure ML API called in Excel, as well as we used Flask used in Python. Teja will go into details of deployment, insights, and model performance in the next section.
Thank you, Shilpi. So coming back to the model, so it's very important for us not just to give the model, right? What is that above and beyond you're going so that your client can use those insights? So for that, what we did was we digged very deep into the data, and we were able to provide some Tableau dashboards. And here, it's pretty much masked because we can't reveal the data what Sound Credit Union has trusted us with. So this is what our dashboards look like. So where we were able to dig into the variables, and we were able to find out what was the problem, like why people were churning and where it was actually happening. So, so what kind of branches and what's the churn rate in those branches? And we were able to analyze, like, so is the churn changing over the period of time, and which were the years where the churn was happening more, and were there any underlying effects to it? So we were able to create those dashboards and give it to the customer. So this is one of our deliverable. And for the next part, where we build the model in Python. So we use different classification models, and one of the important things that we found was that rather than the bagging models, the boosting models had a very high accuracy, precision, and recall. And as you can see here, I have also provided some of the code. And initially, when we ran the model, we got the XGBoost as the best model with 88.7 accuracy and precision of 62.2% and a recall of 89.6%. And one of the important things to know here is that our work is not done here by just building the model. We have to go furthermore, and we need to see whether we can do any hyperparameter tuning and increase the accuracy and stuff. So we went ahead with that, and we were able to hyper-tune and get our accuracy up to 93%, as you can see in the model, and precision for 84%, and recall of 72%. And going next, how we deployed the model. And this is also an important aspect. So we used Azure ML Studio to deploy the model into an Excel sheet where you can just copy the data of your customers and you paste it, and it's going to predict your ML model. And coming back for this presentation, since we can't actually show you the deployed model, so we created a web application to demonstrate the deployment here. Yeah. Just escape it and. One of the perks of being in person after a long time. Yeah, give me that. Oh, there. Yeah. Now you can click on the spider. So this was the code we developed in Spider Python, and when you run this code, so it will create an HTTP model here. That's the address. And when you copy it and paste it in your Chrome or any of the web services, that's where you get the account number. Yeah, this is the demo. And when you slash it and keep loans, then you'll get the model here. And you can just type in the loan account number here. And once you submit it, it's going to say whether the person is going to churn or not. So here, the 8043433 is not going to churn. And let's try some other number and see if our model is right. Wow, that's nice. That's really worked. So the next account number, 4971318, does churn. And these are masked numbers, so I think, Jason, you should be fine. Sure, we masked it. Okay, all right. And going over next, I'm going to hand it over to Shafali for the results and recommendations.
Thanks, Teja. So, hi everyone. Coming to the most fruitful part of the project, the final deliverables, we handed over major 2 deliverables to the client. One, as shown, one was a Tableau dashboard having the insights for the branches who are churning more, so that SU can focus their attention, immediate attention, for those branches where attrition rate is higher. Second deliverable is predictive models. Instead of 1, we came up with 2, as shown by Shilpi. So with one model, we can use any model to implement if a person has both loans and savings account. So we can leverage any of the models which we have built. Third one is according to the agile life cycle, which is shown in the picture here, it is a repetitive process. So the main concern is, as the new data is gathered, it is collected, it has to be rerun in the model so that we can capture the new patterns and member behavior for that. Next slide, please. So the recommendations and solutions are the same. First of all, proactive marketing is very much recommended because instead of waiting for someone to feel like they are about to leave, why not be proactive and offer some attractive offers so that member engagement can be enhanced. This is one of the recommended solution. Another one is, like I said, since it is an agile process, we have to be very actively looking for the data, and we have to run it periodically with the model in order to find the new patterns so that we can accordingly modify those offers also which we have to provide. And the third and last is explore and exploit the model. We are just not leveraging the model for identifying who are the potential churners, but also what we can do next is we can provide them the next best offer, since now we know, okay, these are the particular members who are churning or who are about to churn. At that right time, at that right moment, we can save them and we can basically retain them with the organization for longer, giving them some exciting offers, or the next best offer basically recommends that this is the way to make them stay more. And that is another way to succeed at the slogan itself, that getting through all the ways of life with our members. So now I thank you all for being here, and I open the floor for the questions. Anyone has any questions? Sure.
Yeah, your dependent variable churn, was that based on lifetime, or was it based on that critical 2-year period?
So the question is, the dependent variable churn, was it based on the lifetime or a time period? So it is just based on the closing date. There was a closing date variable. If in that closing date variable column, there is a positive number, I mean a date, not null, so that's 1, otherwise it's 0.
To add to that, we used past 5 years of the data. And the point to remember here is that customer trends keep changing, so they're not always the same. So that's why we mentioned to the client that we give you the model, and you need to keep running at periodic periods, so that if there is any change in the customer patterns, they'll be able to capture that, and even the model is able to capture that, and you go into the right amount of churn that you're expecting.
One question. So your goal is to improve the retention rate, right? So when you are improving the retention rate, did you account for the other KPI metrics within the business, whether it will affect the other metrics within the organization? Like for example, if you take active users, what happens if you increase your retention rate? The active users count goes up or down. Is there any causal relationship between those two?
So the question is, your goal is to increase the retention rate, and how it affects KPI. So first, a small clarification. Our goal for this one is to identify the features which can lead to churn. And of course, that will give the insight to increase the retention rate. Actually, what we know that next year there would be another project called Next Best Offer, and they would be taking this from here and work on that, increasing the retention rate based on Next Best Offer. Did that answer your question? All right, thanks.
Yeah, so my question was, I'm not sure if you can disclose or not, but what defines a customer who is likely to churn in a loan account versus a savings account, and how does that vary?
Thanks a lot for the question, sir. Let me, so the question is that, what's the difference between the two models, if I'm right, and what are the variables that are going to affect
Customer in loan versus savings?
Okay, what characterizes customers to churn in a savings and a loan account? So that was the main reason why we built two models. We could have built like one single model for both loan and savings. And what we found out was a lot of good variables are being left out when you create that model, right? You probably take the top 25 of them for defining it so that you don't make it very complex. And when that's happening, you're losing credible information. So what we thought, like, okay, let's see what's going to happen if we create a savings model and a loan model. And through these models, what important insight we got, which happened unconsciously, was we were able to derive at a point where we could say that, okay, these loan features are actually very important for account holders who are having only loans. And these saving features were very important for the people who are having only savings account. So what happens here is you're able to retain that knowledge, otherwise which would have been lost if you had created one single model combining all of them. It would have still worked, but you won't be able to get those good insights into it. And that was the major reason why we have created two models. I hope that answers your question. Thanks a lot. Yeah.
Question. Did you use that any credit score in order to distinguish which customer will be work perfectly or not? Because as you know, we have a credit score, and there's so many credit score companies actually scoring the people in the United States. And does, that credit score may be a representative about that person can be, return their loan or not?
Yeah.
So the answer to that question before, without breaking confidentiality is, we were provided a credit score, but we cannot disclose whether we use that in the model or not.
Just sort of in an industry context, what does churn look like for a loan? Is that because loans typically are needs specific, right? Is that does the loan transfer? Do they not repeat with a new loan? What's that look like?
That's very interesting. And one important thing that we found, and thank you for the question, Chair. As you understand, there might be some people who would just take the loan, and once they finish the loan, they're going to exit it, right? And I think that's the context you're coming in from. Yeah, so that's the reason why we had some feature engineering done, and after running the model, we took out the feature importance, which we're going to exactly tell that is the closure happening because of the member, like filling up his loan, EMIs and everything. And I couldn't go much into detail of it, but those insights, we also went back to Sound Credit Union and asked, hey, does this make sense to you? And they came back to us like, okay, this variable, I don't think so you can use it. It doesn't work out in the domain expertise, so you can, because one of the feature we got was very important. And when we got back to, because we are not like domain experts in it, we are only the data experts. And those people were the domain experts, and they guided us at the time when we asked that, hey, these were the important features, what do you think about it? And they came back to us, yeah, these are the important ones, and this is not the important one.
All right, nice job, thank you.
Yeah. Thank you.
We also like to invite you for the poster session, which is going, just follow the session. Thank you.
Doing my job, thank you for that. Well done. And because Jason is here, I just want to call out Sound Credit Union. You've been terrific partners with us through the years on applied projects and others, so we really appreciate your investment in time in our students and their learning. Okay, we are at the last presentation. Actually, not the last. We'll have the AI Club being last. Team number 8, come on up.
Good morning, everyone. My name is Aradhana Mishra, and we are Team 8. Our client is Common Spirit Health, and together we are working on the project Telehealth Adoption Utilization Assessment. We are a team of 5 members, Shreya, Gautami, Shivangi, Siddhant, and myself, Aradhana. Our client representative name is Kendia Perkins, and project sponsors are Dr. Gary and Dr. Gray. We also like to thank our CBA team, which helped us throughout this project. Common Spirit Health formed in 2019 and has presence in 21 states with 140 hospitals. They advocate for poor and vulnerable communities. They donate $4 billion annually in charity care. What is telehealth and why it is important? Telehealth allows your doctor to provide you care without in-person visit, using digital informations and communication technologies such as mobile computer devices. Telehealth has various benefits, such as less exposure to illness from patients, increased flexibility, and reduced no-shows. We have used various tools and technologies during this project, which includes Power BI, RStudio, Excel, Tableau, Cognitive Services, Azure, SQL Server. Next. Market size. We have seen a significant increase in market of telehealth adoption during 2020 and expected to grow $43 billion USD by 2026. Objective. The objective of this project is to evaluate the practice setting and community characteristic of telehealth adopters across the state and healthcare organizations. Secondly, to evaluate the variation in telehealth utilization by patients based on their demographic and geographic information. And thirdly, how does the COVID impact telehealth utilization? Now, I would like Gautami to continue with the next slide. Thank you, everyone.
Thank you, Aradhana. So we'll see the project approach in the four phases of the project. First is the discover and plan, in which we did the industry and the market analysis and understood what is the data with the help of data dictionary and with the help of our client. In the second phase is design and analysis, where we understood the data fully and did the data visualization and delivered the insights about the data to the client. Then third is a developed solution, where we build the predictive model with the help of R. And then fourth is the deploy solution, where we use the cognitive services and do the cognitive analysis and propose the recommendations to our client. Next slide. Here is the high-level architecture of the project. So first, our data was present in multiple EHR systems of the client, and then they fetch their data into the internal database, and they perform the ETL process to share their data in the shared format, in the share file format to us, and where we perform the ETL services and then uploaded the data into the Azure SQL Server, which is provided by the UW University. And then that data is being used for the creating dashboards, reports, and in the Power BI process. So for the data preparation and data cleaning part, we got the data into multiple flat files, where we combine all the flat files into one and then perform a data analysis using RStudio. Going ahead, we perform a data cleaning on the Tableau prep and sampled our data with the help of Azure ML Studio, which is 30% of the data, and then uploaded that data into the SQL Server database, which is provided by University of Washington, and then use that data for further analysis. Moving to the Power BI visualization. Yeah, so first dashboard is all about demographic, where you can see on the left hand side, there is like measure amount of age groups which are from 40 to 70, which are in patients are more in the 40s and in 70s. Then moving to the right hand side, there is a race which is like white are in more in common. And I would like to tell more about the data is like we have 2 years of data, 2019 and 2020. And whole data is segregated into the virtual and non-virtual data. Green part is non-virtual data, whether the orange part is virtual data. In the ethnicity, non-Hispanic and Latinos are more, where in gender and the discharge year, you can see females are more in count than the males. Then I would like Shivangi to take over.
Thank you, Gautami. So now we'll move on to SG2. What is SG2? They are category groupings in terms of different illness. There are different types of SG2 categorizations. We'll start with the SG2 procedure group category to the top right. Here there are different groups. So if we select to either one, for example, lab, we can see there are different procedure groups and service line groups as per them. So this will help them to understand which procedure group is higher in terms of virtual or non-virtual healthcare. Let's move to predictive model and evaluation. So we had to, the main important part is to classify if the patients are going to be turned out as virtual or non-virtual. For that case, it's a classification problem. We performed classification, but before that, we had 50 variables. So, and it was difficult to do analysis for those 50 variables. So we did permutation feature importance. This helped us to understand the top variables which are important in the whole model. We performed various classification models like logistic regression, random forest, decision trees, and amongst those, we compared different scores and found that logistic regression has the highest accuracy, along with the recall, precision, F1 score. We also compared different AUC, ROC curves, and this also reflected in the logistic regression as the best model. Let's move on to the cognitive analytics. In terms of word cloud, what you can see in the screen is different types of short description for all the illness. You can see it like the acute and chronic are highest in terms of 2020 virtual data, which helps us to understand which diseases they can classify more as virtual in future. In terms of recommendations, we had various recommendations. For example, the first one is they can start with their initial screening as virtual. This will help in multiple places. It will, like the point 4, it is a low-cost alternative because the traveling and everything is saved. Alternatively, they can also educate people about the importance of virtual healthcare. Like in this COVID scenarios, it's important like not to be spread it. They can make higher investment in different age groups like 40 to 50, as showed by Gautami, that women had higher share than men, so they can concentrate on men. I would like to thank everyone on behalf of the whole Common Spirit team. Thank you for your time. Any questions? Thank you.
Thank you. One more to go. The AI Club is coming up in about 5. For project with IBM, I can't wait to hear what you're like.
Good morning, everyone. I welcome you all on behalf of AI Club team for our last and final project of today, which is AI Fairness 360 Toolkit, which was performed in collaboration with IBM. This will be our main agenda for today. We'll start off with our project team. We'll have a quick introduction about AI trust and fairness and the AIF 360 Toolkit. And we'll have a short project demo. After that, we'll conclude this presentation with the results and recommendations. On the right side of it, you can see our project team members, myself, Nitisha, Teja, Shefali, and Moni. And we would like to extend our thanks to our client representatives and our product owners, Andre and Sanjana, for giving us this opportunity to perform this project. And we would like to extend our thanks to our CBA team for equipping us with tools and knowledge to perform this project. The main scope of this project here is to understand AI trust and fairness and what are the metrics which are available in AIF 360 Toolkit to mitigate bias in data sets. And the main project objective over here is to run the data sets through the metrics and algorithms which are there on AIF 360 and to create a use case presentation out of it. This project was completed in total 12 weeks by getting acquainted with AIF 360 Toolkit. After that, we performed certain analysis with it and understanding deep learning and artificial intelligence to perform the analysis. And after that, we have tested the algorithms and metrics on different data sets, and we finally have submitted the deliverables to close the project. So AI trust. Artificial intelligence is becoming one of the major factors which is driving to make decisions in every industry nowadays. So we have to ensure that AI is trustworthy to make those decisions. So these are the 5 aspects of AI to be trustworthy, which starts from fairness, robustness, explainability, transparency, and privacy. We are majorly focusing on fairness as a metric and as an aspect today. I request Shefali to take over from here.
Thanks, Nitisha. So coming to fairness, any AI or ML system, decision-making system which has bias can not only fall under legal issues, but also it falls under ethical boundaries. So that's why fairness is very important for a system to be having so that it is not biased anymore. And the results also will not be biased. Why it is difficult? Since fairness has over 21 definitions when it comes to different areas where it can be applicable. So that's why it is pretty much difficult to understand which particular system or area will have which kind of fairness. Now, the solution is AIF 360 Toolkit. It is an open source toolkit, and it is a very comprehensive one because we have over 70 fairness metrics and over 10 mitigation algorithms which help us to mitigate bias. So where does bias come from? This is the main question. So there are many methods through which bias can be induced through our data or through the system which is capturing this data that can also induce bias. And of course, the person who are the end power for decision-making system, they might knowingly or unknowingly can bring bias to the system. And why we cannot skip these features which can create bias into the model is because they might be correlated with many other features in the model, and eventually just removing those features will not help us in removing overall problem or removing any biasness in the model. So since I told that over 70 metrics are there for fairness, here we have presented basically few, and we are mainly concentrated on disparate impact, which states the ratio for the favorable positive outcomes to the unprivileged groups to the privileged groups. Next slide, please. Here, in this slide, we are having overall baseline how we should approach an AI fairness problem. And we can basically apply the algorithms in these 3 phases. First is pre-processing bias mitigation algorithm, which is applied when we have not actually run the model. Just before running the model, we can apply this algorithm. In processing is bias mitigation algorithm where we apply it while running the model while training the data. It basically fixes the classifier. And third one is the post-processing bias mitigation algorithm, which is basically applied to results or on the predictions. It basically considers, follows the path for where the system is basically a black box. In this slide, this is a basic guideline how we should actually follow the steps towards providing a solution for a bias fairness problem. So first of all, we should be very careful for the data which we are collecting, and we should be very clarifyingly, we should mention which particular protected attributes we are using and what will be the thresholds for that. Since we have many fairness metrics available for us, we have to find out which is applicable for our particular use case. Secondly, we should apply the algorithm in particular to our data set, and wherever we have access, we should use that particular algorithm. Like I said, in process, pre-process, and post-process. Thirdly, once we have already applied the algorithm, we can check the bias metrics and trade off how we can reduce the bias in the main model. Now I would like to hand over to Monica to show the use case of the project.
Hello everyone, thank you Shifali. To develop a use case for this particular project, we have utilized a bank churn dataset in which we will show how, while predicting whether the customer is going to churn or not, how bias can occur in the dataset and how we can mitigate it. So this is the characteristic of the data set where 20% of the data have churned or exited and almost 80% are not churned. Now I want you to observe the second visualization where there is the spread of gender across exited and non-exited. And as you can clearly see, though there are more number of male respondents in the survey, there are actually more number of female churners in the data set. So clearly this will bring a bias since while building the model, it will penalize one of the groups for having more number of favorable outcomes than the unfavorable outcomes. And yes, and here I want to show you how we have calculated the bias in numbers. We have assigned the labels of privileged and unprivileged groups to male and female. Then we have calculated the ratios for from the unprivileged outcomes to the number of privileged, and we have finally found out that the disparate impact ratio stands at 1.53, which indicates that the model will give higher weightage to the unprivileged group for having higher number of outcome variables, which is exited or churned in this case. Now this is the, our objective is to reduce this number from 1.53 to the benchmark of 0.8 to 1.25. And for utilizing that bias mitigation algorithm, we have imported the necessary libraries and we have fit the pre-processing disparate impact remover algorithm into our data set. Next slide, please. After transforming the data set, we have once again calculated the disparate impact remover, and now the ratio stands at 1.27. So our algorithm has successfully reduced the bias from the unprivileged group standing at 1.53 initially to 1.27. So this indicates that our model which we are going to build, our predictive model, it will have less bias than the original data which had been biased towards the unprivileged group, which is the females in the group. Next slide, please. And after transforming the data set, we have tried to find out the accuracy metric using the logistic regression data and the logistic regression model. The accuracy stands at 0.789. This indicates that the new model that we have built has treated all the variables fairly, and our model is bias-free. I now request Teja to take on the presentation from now.
Thank you, Moni. And so what we did was we tried the algorithm on two different models. One is the bank churn data set, and the other is a heart rate disease data set. And as you can see here in the slide, even though we were able to reduce the metrics from 1.53 to 1.27 for the bank churn, the accuracy remained same. While for the heart disease data set, the model disparate impact improved from 1.81 to 1.07, while the accuracy has actually improved. This might not be the case always, and there might be some reductions in accuracy when you utilize these algorithms, and I'll get back to that in the recommendations. So here I'm going to tell you about the recommendations and trade-offs. Now, who actually in the industry can use these algorithms? So that's a very important for us. It's a fairly very new topic. It's there from old, but it's gaining a lot of importance nowadays. And any decision-making system where you think the privileged or unprivileged class are going to get affected, you want to use this AF360 and make sure that you are not biased towards any of those class. So down the line, just making sure that you're not getting into any legal or ethical problem. For example, let me see, I think there was a time when Amazon developed a resume filtering system. What it was doing is, since majority of male applicants were there in the pool, the data they used, it started biasing towards the male gender, and it started rejecting some of the female applicants. And it happened unconsciously, you don't know that was the thing happening because the algorithm picked up the bias in the data set. So not only there, in any cases, maybe universities where you're trying to use the AI system to access the admission data and everything, and making sure that some people are getting admitted only by using the AI system. So you need to make sure that it's not getting biased anywhere. And the trade-offs here are that, as I said earlier, it might not be always that your accuracy might improve or remain the same when you use algorithms. It might reduce a little bit, and you need to take a call based on your business perspective, whether you need the accuracy or bias, which one is more important for you, or how you can balance both of them. And one of the important things for the AF360 toolkit to work is that you need to be very clear on what your privileged and unprivileged class is. And your data set and your business case has to be very crisp and clear so that you can apply this AF360 algorithms. And also, from what we have seen on the data sets, it's always good to use those algorithms before you run the model. And in case you can't, it's a black box model, then you can always go for the post-process algorithms. And going forward, what the team is thinking of is going into the explainability of all those algorithms and going further into the AI trust model where there are others things like privacy, explainability, and transparency. And now I'm going to open the floor for questions and answers, and this is our excellent team, and our LinkedIn profiles are here. Just in case if you have any questions, our emails are also there so that you can shoot us those questions, and you can always put it in the YouTube live link, and we'll go through that and answer those. Yes. Thank you. Thank you. Yeah, Michael.
Yeah, so, oh boy, I get the hot mic here. In thinking about the use case, and I saw in your recommendations that this can be applied to any data set, but that initial measurement is feature-based. Is that correct? Okay. So is the use case for that the recommendation to, when we think of bias, right, when we're modeling, we're always trying to indicate or replicate or mitigate for what's actually happening in reality, or to represent that, right? Some variables, it might be easier to identify initially, or we might have a hunch to say, oh, we should measure this here because we know in society or in reality, these are opportunities where bias happens, be it gender, be it race, et cetera. Looking strictly at the data now and taking context out of it, I mean, anywhere where we have a class imbalance, which is common, right, within categorical features, is that where we should be applying this to take a measurement to test in advance? Or what would be the guidance if, in terms of our general data exploration, right? How do we use this thing most effectively? You know what I mean?
Thank you for the question, Michael. And that's why I've been stressing out a lot that your business model and your data model, the users have to be very clear what your privileged and unprivileged class is. And that's what you need to establish beforehand, before addressing, like basically for any project, right? The first thing that you might encounter is, hey, I think there are classes where it's getting unprivileged and they're going to use it. So it's always necessary for you to come up those privileged and unprivileged class in the business case. And as usually, there might not be the case for every class. Usually what happens is your most protected variables are kind of age, gender, or ethnicity. This is where the major bias happen in the industry, which would actually fall into the legal or the ethical boundaries. So these are the main categories that you want to look into and find it out about that. Yeah, actually.
Similar question to Michael. So how is this AI bias treatment any different to solving for a class imbalance problem where you could do undersampling or oversampling for like a minority class or the majority class? So how is this any different than from that?
Yeah, that's a very interesting question. So usually what happens when you do oversampling or undersampling, you can see that some of your data is getting repeated when you're doing undersampling, and that's not, you actually might increase the bias in that set because you're having the same rows getting repeated. And when you're doing, this is the case for, when you're going for undersampling, like reducing one of it so that it matches with both the classes, you're going to lose your important information, and you don't want to go there because that might give you some results, but it's not trustworthy anymore. So that's where this AF360 comes in. You can do over and undersampling for a few of the classes, but when it comes to the privileged or protected class that you're going to decide upon, it's always better to go this with AF360 algorithm. Yeah, thank you. Thanks a lot, everyone.
Well, we're wildly off schedule, and I don't care because this is a lot more fun than listening to us talk about CBA and applied projects and whatnot, but there's still some folks on YouTube, and I just want to make the plug. So I think you've seen the tremendous work our students do with our partners in applied projects, and we've got a bunch of new students coming in. Some are right here. So this is a call, the 6th annual call for applied projects. They're due June 10th. I could be a little flexible on that. They're due June 10th. Simply all you need is an opportunity, data, a problem to solve, a whole lot of data. And as Michael Turek says, our students love a lot of data and they love predicting things. So if you've got that and you'd like to partner with us, please get in contact with me. And my email is helsem@uw.edu, and I can answer any questions. This was a terrific day, a terrific moment, a terrific morning. Thank you. What's next is lunch. Got a bunch of lunches waiting out front. And then we will start cleaning up this room and getting it set up for the poster session, and that'll start at 12:30. Anything else, Anne-Marie? I'm good? Haluk, would you want to say any parting words? No, he's good. All right, let's eat. Thanks. Good job.